So in question 9, we are given a conducting rod of length L. It is moving at a speed v at right angles to this magnetic field. We need to use a law, Faraday's law or otherwise, to show that V is equal to, the potential is equal to VBL. So with Faraday's law, we know that the induced EMF, so the potential is minus N times the rate of change of flux. So let's see how much the rate of change of flux is. So let's say the rod moves down some distance, like let's say over here. The rod moved down, it has swept out this much area here. So what we know is that it has a length of L, so this side of the area, so the area, if we write down the expression, is going to be the area of this rectangle, so it's base times height, so L times the height of it. And well, it has moved for a speed with a speed v for some time t, so we can say that this is v times delta t, just how long it has been going for, as velocity times time is distance. And so what we can say is that the rate of change of flux is going to be, well, rate of change of flux is flux is b times a, and the rate of change of that, the flux is constant because the field strength is constant. It's only the area that is changing. Therefore, we can say it's b times delta a, and the change in area we have already calculated. There's b L v times delta t. And then we use EMF, the Faraday's law. We know N is equal to 1 as we only have one rod here. So we have b L v delta t divided by delta t. So these cancel out and we just have BLV or VBL. And then in part 2 of A, we need to identify the end of the rod that becomes negatively charged. So what we need to do here is use our right hand to calculate this. So let's say that we are considering the protons. Let's say we are a proton at the middle of the rod and we are moving downwards. So if we point our thumb down, so like towards us down the page, the field is into the page. So the protons will have a force on them pointing to the right. Therefore, the electrons will have a force in the opposite directions. So they'll be moving to the left. So they will be on the left end of the rod.